Welcome to all. This is Nandhini, Assistant Professor, Department of Computer Science and Application from DKM College, Vellore. In this session, we are going to see about cryptography's concept and then its algorithm. So here we are going to see about encryption algorithm. In encryption algorithm, there are two algorithms, symmetric algorithm and asymmetric algorithm. In symmetric algorithm, we use a single key for encryption and decryption. And in asymmetric algorithm, we use the pair of keys. One is public key and another one is public key for encryption and decryption. Here we will see about symmetric algorithm. It is also called as secret key cryptography. Here we use a single key for both encryption and decryption. Key must be known to the both parties. One is a sender and another one is a receiver. Here, plain text is given to the encryption algorithm with the key, and then it will generate a ciphertext, and after that the server will give to the decryption algorithm. Decrypts occurred after we get the original text, that is a plain text back. So now we are going to see about asymmetric algorithm. Already we see the asymmetric algorithm. We use the public key and private key. Here public key is used for encryption and then private key is used for decryption. Here the diagram itself I have shown that this is the plain text. When we encrypt with the public key, we got the ciphertext, and then ciphertext is decrypted with the private key and we get the plain text back. So here symmetric algorithm, there is a DES, AES and IDEA. DES is nothing but data encryption standard which use the 56-bit keys, and AES is nothing but advanced encryption standard which uses 128 and 192 or 256-bit keys. IDEA is nothing but international data encryption algorithm which use 128 bit keys. Then DES is developed by the IBM, which is known as data encryption standard. It is also called as data encryption algorithm. In DES is careful and complex combination of two fundamental building blocks of encryption. One is substitution technique and another one is transposition technique. DES is only used standard arithmetic and logic operation on numbers and up to 64 bit long. This is the DES process. First, the plain text is 64 bits, which is given to the IP. IP is nothing but initial permutation, and then it's separate into off. One is LPT and another one is RPT. LPT is nothing but left plain text and RPT is nothing but right plain text. And it perform 16 rounds with the key. LPT is go under 16 rounds and RPT will go under 16 rounds separately with the key, and then it combined with the final permutation is occur on the combination. Finally we get the ciphertext 64 bits as the result. So here I noted the steps. So first 64 bits plain text is handled over the IP, this initial permutation function. IP is performed over the plain text. Then two offs will be separated. One is LPT and another one is RPT. LPT and RPT goes under 16 rounds of encryption process, each has with the own keys. LPT and RPT are rejoined and final permutation performed in the combination block, and we get the 64-bit ciphertext. Now this is the single round. We saw that's the 16 rounds. This is performed with a single round, one round. So first key transformation occurs in 64 to 56 bits, and then expansion permutation occurred in the 32 to 48 bits, and the S box substitution is under 46 to 32 bits. P permutation will occur, and then odd XORed with LPT. LPT is the left line text, and or else RPT. RPT is nothing but right line text, and then swap. This is the process of following the single round. Now we will see about the advantages and disadvantages of DES. So here advantages is used in it's an ANSI and iOS standard. Anybody can learn easily and implement it easily. It's hard to crack. And then disadvantages of DES is software implementation of DES is very low, very slow. Okay, here asymmetric algorithm. Asymmetric algorithm. In asymmetric algorithm, we use RSA. RSA is nothing but revert Summer Altman encryption, and it is based on the factorization of product of large prime numbers. And snapshot algorithm. If m1, m2, mn are given values, s is sum, s equal to b1 multiple with m1, b2 multiple with mn, and bn multiple with mn. Let's go on. Here where bi can be 0 or 1. Bi is nothing but b1, b2, b3. It will go on. Its value will be 0 or 1. Here we see RSA algorithm. RSA is named after three scientists, I mean three inventors. Who invented RSA algorithm? Ribot, Schimmer and Altman. This algorithm was introduced in 1978 and to date remain secure until now. RSA has been subjected to extensive cryptanalysis. Cryptanalysis is the how to break the ciphertext. So cryptanalysis are no serious flaws found in the RSA algorithm until today. Encryption algorithm based on the underlying problems of the factorization of large numbers. Then now we will see how to generate private and public key. So we need to pick the two prime numbers. Here I pick the p equal to 3, q equal to 11. Both are prime numbers. 3 and 11 are prime numbers, right? Then calculate n equal to p into q. P into q is I substitute 3, 11 here. This is the formula to calculate n. So 3 into 11 equal to 33. And then we calculate z value with the formula p minus 1 into q minus 1. P minus 1 is 3, p is 3 and q is the 11. So 3 minus 1 multiple 11 minus 1 equal to 20. We get the result as 20, z equal to 20. Choose the prime number k. Here we choose the prime number k such as k is the co-prime of z. Co-prime is nothing but z is not divisible by k. Okay. Then we have several choices for k. Until this condition follows, we have several choices. 1 is 7, 11, 13, 17 and 19 is go on. Then let's pick I pick randomly 7 here. Okay. So the number n equal to 33 and k equal to 7. 7 is the server public key. Now till now in the transmission, server has to calculate its secret key. This is the formula to calculate the secret key. K star j equal to 1 mod z. Mode is nothing but remainder. When we divide the numbers, remainder value will be the mode value. So here I substitute k equal to 7. We already find k equal to 7. Choose, right? Here substitute 7 star j equal to 1. Mode 20 is that value already find in the last line. Okay. So I substitute 20 here. So now 7 star j divided by 20 equal to 1. So here we see remainder value will be 1. Okay. What we get remainder value? So difference will be 1 only. Okay. So 21 by 20. We get the remainder value 1. Okay. Then now see 21 7 star j equal to 21. So what is the value of j? J will be a 3. Okay, this is our secret key. So here 7 star 3 equal to 21. Okay, I mean 7 into 3 equal to 21. So this is our secret key. Then we need to now we find the secret key. Now we need to encrypt the message. So here is the formula. P to the power of k equal to E mod n. Here P is the plain message. We can choose any numbers, 14 or 16, 17, any numbers. Here I will choose 14. 14 as the P. P is the plain text we want to encrypt. This will encrypt to get the sum value as a ciphertext. So here E is the encrypted encrypted message. We get the final answer. We need to substitute k and n here. So n and k are servers public key. We already see. Then here I substitute p equal to 14 and k equal to 7, n equal to 33 here in the formula. This equation says 4 to the power of 7. Okay, 14 to the power of 7. 14 to the power of 7, we got the value 105,413,504. Okay, then we need to divide with 33. When we divide with 33, we got the value 3194348.606. Okay, then we need to multiply with 33. So what is the resulting value? 3194348 into 33 equal to, we got the answer 10541,348. Here we need to subtract with the power value. Okay, so here 10541,3540 minus 10541,348. What is the difference? 20. So 20 is the encrypted message. This is the steps we need to follow. This is the constant step. Okay, then we got the encrypted message. So we need to see encrypted message. We got encrypted message. We need to get back the plain text back with the encrypted message. We will see. Okay, then encryption. Yes, equal to 20. Now we need to. Now the server will receives the message and it will decrypt the encrypted message. When we decrypt, we get the plain text back. Decryption of the message. That is the formula e to the power of j p mod n. So we need to substitute here E is the encrypted message. What we receive? Encrypted message. Okay, J is the secret key and then N is the server public key. We need to substitute N value, E value, J value, we will get the plain text. Okay, 20, we already get to 20. 20 to the power of 3 equal to P. I substitute N equal to 33. So 20 to the power of 3 is 8000 divided by 33. What is the remainder value will be the remainder value of the P. Okay, so we need to calculate remainder value 8000 by 3. What is the remainder? 242.424242, it's gone. Okay, now we take the 242 multiple 33. When we multiple both, we get the value 7986. Now we need to subtract. Already we saw in the encryption. So as like that we need to decrypt here. So we need to subtract with the power value. 8000 minus 7. What we result we get? We need to subtract with that. 7986 equal to 14. So we get the plain text back. Okay. Thank you.